Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syamil bin Supaiman. My metric number is AA191999 and I'm from section 3 for Industrial Electronic. Today I'm going to explain about the ladder diagram for problem statement 1. Okay, so I have identified the input and the output for the problem statement. Okay, so the input is push button normally open, which label PB1, and limit switch normally open LS1. The output is relay switch off delay label with R1, indicator lamp and label lamp, and also solenoid coil label with 1Y. So here is the ladder diagram, and down here is the pneumatic diagram. When I push and hold the PB1, the current will go through the relay switch of delay and energize it and cause the contact become closed. When it become closed, the current will flow to the solenoid coil and energize it and will make the valve change state and allow the air to flow to the cylinder. When the cylinder has fully extended, the limit switch will be closed and the current will flow to the indicator lamp and make it turn on. When I release the PB1, relay switch of delay de-energize and start counting down for 4 seconds. After the counting down end, the contact will become open and it will de-energize the solenoid coil. So the solenoid coil will change state and will cause the cylinder to retract. So the limit switch will become open and the indicator lamp will turn off. So this ladder diagram has fulfilled the problem statement 1.
Hello and Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Khairul Nazmi bin Muhammad. My matrix number is AA191588. Today I will be presenting about the solution for problem statement 2 for our group assignment. So what we are going to use inside the FluidSim software are two air service units and two single acting cylinders, two compressed air supplies, two 3-2-way solenoid valves, limit switches, relays with on delay, two indicator lights, solenoid valves, and two push buttons. So, firstly, as stated in the problem statement, a start button is used to turn on conveyor belt A that brings the bottles to a filling station. So I will simulate the circuit and we will observe what will happen. As I press the start button here, okay, we can see that the current will flow and energizes R1 and it will change its contact to a closed contact and It will allow current to flow through Z1, which is solenoid valve. Then VA sensor here will detect the presence of the bottle, and it will stop the conveyor belt A for 2 seconds to fill up the bottle. As you can see here, 2 seconds. 1, 2. Okay, then the conveyor belt will continue to move until it reaches sensor S2. After that, S2 here. After that, solenoid valve Z3 will be energized for 3 seconds to push the bottle onto conveyor belt B. So for 3 seconds, as you can see here, 1, 2, 3. Then the process is repeated for other bottles until a stop switch is pressed. Here, it will continuously. Then, if I press stop button, it will stop. So when I press the stop button, the process will not be repeated. I think that is all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Azmi Naim Bahmat Kamil, and I will continue for the problem segment 3. So this is the pneumatic system and the ladder diagram based on the question 3. We got 3 single acting cylinder denoted as cylinder A, B and C. Next we have 3 solenoid valve with relay control denoted as Y1, Y2 and Y3. And lastly we have sensor inside the cylinder denoted as S1, S2 and S3. So based on the process sequence of the question, initially Y1, Y2 and Y3 are not energized. The initial position of cylinder A and C is retracted while cylinder B is extended. Start button is pressed, cylinder B is retracted. Sensor B detect full retraction for cylinder B. After 3 seconds, cylinder A extend. Sensor A detects maximum extension for cylinder A. After 4 seconds, cylinder C extend. All system reset off when sensor C detect maximum extension for cylinder C. The system will reset or off when the emergency button is pressed at any time during the operation. As we can see here, cylinder A and C is retracted and cylinder B is extended. So let's run the system. So basically when we press the PB button, the current will flow to relay K1, thus will make the relay K1 energized. Once relay K1 is energized, the relay contact here will change the state from open to close, hence it will let the current flow to the parallel collection into the relay K1 to make the relay K1 continuously energized. In the meantime, the relay contact of the second round will also become closed and the current will flow to the solenoid valve Y1. Hence, it will make the solenoid valve Y1 to change the state and let the A flow into the cylinder B, thus will make the cylinder B to retract. Once the cylinder B is fully retracted, it will trigger sensor S1, thus the switch S1 will be closed at the third round. Then the current will flow to the relay on delay timer T1 that we have been set the timer for 3 seconds, and after 3 seconds relay contact T1 will close and the current will flow into the solenoid valve Y2. Thus it will make the solenoid valve Y2 change the state and let the air flow into the cylinder A, and it will make the cylinder A to extend. Once cylinder A is fully extended, sensor S2 will trigger and it will make the switch S2 to become closed and will let the current flow into round number 5. At the same time, it will energize the relay on delay timer T2 that we have been set for 4 seconds. After 4 seconds, the relay contact T2 will be closed and the solenoid valve Y3 to activate. Hence, the cylinder C will extend, and after it fully extended, it will trigger the sensor S3. Thus, it will make the current flow into the relay K4, and the relay K4 will energize. Once it energized, the relay contact here from normally closed to become open. Thus, it will cut off the current connection that goes into relay K1, and the relay K1 will de-energize. Once the relay K1 is de-energized, it will cut off all the subsequent connection, and the system will turn back into the initial state.
Assalamualaikum. My name is Muhammad Ikmal Benjamin Salwi. My number matrix is AA191616 from Section 3, Industrial Electronic. For my part, I will present the problem statement number 4. Problem statement 4. Figure Q4 show the PLC CPM2A used to start and stop the motor for a segmented conveyor belt. The object is passed from one conveyor to the other. Proximity sensor located next to each conveyor segment. Sensor 1, 2, and 3 are used to locate the position of the object. Assume there is only one object per cycle. The process sequence as per follows. When start button is pressed, motor 3 turns on. Motor 3 is always on unless the stop button is pressed. Sensor 3 detects the object. Motor 2 turns on. Then sensor 2 detects the object. Motor 1 turns on. Number 4. After 2 seconds, motor 2 turns off. Then sensor 1 detects the object. After 2 seconds, motor 1 turns off. So let's make an analysis from the problem statement. So these are the analysis came from the problem statement number 4. The analysis is divided by two segments, which is input and output. So let's take a look. As I mentioned from the problem statement, the motor 3 is turned on by pressing the push button, and it will stop by pressing the stop push button. So we will be using the push button, normally open switch, with the description of PV1 for the start push button in this problem. As an output, the motor 3 will turn on. However, we will be using the indicator light as an indicator for the motor 3 to turn on. The description for the light is motor 3. Then, as I mentioned from the problem statement, the motor 3 will turn off by pressing the stop push button. So in this problem, the indicator of stop push button is push button, normally close switch, and the description of this push button is PV2. At the output segment, motor 3 will turn off, and the indicator light is used to show the output of it. Next, sensor 3. Sensor 3 is function to detect the copper plate on the conveyor belt. The motor 2 will turn on. So in this problem, we will be using push button, normally open switch, as an indicator of the sensor with a description of PB1. As an output, the motor 2 will turn on when the sensor 3 detects the copper plate. So in this problem, we will be using an indicator light for the motor 2 in order to show that the motor 2 is operated with the description of motor 2. Then sensor 2. Sensor 2 is function to detect the copper plate. Then motor 1 will be turned on. So the push button, normally open switch, will be using with the description of PV1 as an indicator for the sensor 2 to works. While the output segment, the motor 1 the motor 1 will be turned on. However, we will be using the indicator light with the description of motor 1 as an indicator for the motor 1 to works. Next, from the previous problem statement, the motor 2 will be turned off after 2 seconds. So we will be using the relay switch off delay in order to turn off the motor 2 back as an output. Our motor 2 will be turned off. Lastly, sensor 1. For the sensor 1, we will be using relay switch off delay with the description of C31 as an indicator for the sensor 1 to function. Then motor 1 will be turned on. Next, by referring to the problem statement, the motor 1 will be turned off after 2 seconds. So the use of the relay switch off delay is a method that will be used in this problem because it can turn off the motor 1 back after 2 seconds. So let's continue with the discussion of problem statement number 4 by using the ladder diagram. So these are the ladder diagram that I set up in order to answer the question. From the question given, the start button is pressed, motor 3 turns on, and motor 3 is always on unless the stop push button is being pressed. Therefore, to make that happen, we will be using the latch method in order to answer this question. As we can see, the coil C1 is having a latch with push button PB1, start push button. So when the current is flow, the coil C1 will be energized. When the coil C1 is energized, there is no need to hold the PB1 in order to let the current through to PB2. Besides that, the relay coil C1 also will be energized. However, when the PB2 stop push button is pressed, the PB2 will be open contact and not allowing the electric to flow through it, electric current to flow through it. Thus, the relay coil C1 will be de-energized and also coil C1. However, if the PB2 is not being pressed, the motor 3 at the rung 2 will be functioned due to coil C1 is energized. At the third rung, PB1 will be used as a sensor 3, which is when the object is being sensed. The relay coil C21 will be energized. Thus, the switch C21 at rung 4 will be in close contact and on the motor 2. However, the relay coil C21 at rung 3 is a relay switch off delay, so it will be energized only for 2 seconds. Then it will be de-energized back. When the relay coil C21 at rung 3 is de-energized, the switch C21 at rung 4 will be open contact and make the motor 2 to turn off. At the fifth rung, the PB1 will be used for sensor 2. So when the sensor is sensed the object, the motor 1 at rung 6 will be turned on. So as we can see, when the sensor 2 is sensed the object, it will let the current to flow through it and let the relay coil C31 to be energized and make the switch C31 at rung 6 to be in close contact, which is make the motor 1 to turn on. However, in this question, motor 1 needs to be in off condition after 2 seconds. So at the rung 5, the relay coil that is used for C31 is a relay with switch off delay. So it only operates with delay of 2 seconds only, and it will be de-energized back. So let's take a look. Start. Motor 2 turns on, motor 1 turns on. When the sensor 3 is detected, motor 2 turns on. When the sensor 2 is detected, motor 1 is turns on. And it turns on for 2 seconds. 1, 2. So when the stop push button is being pressed, there is no current flow anymore. So that's all the explanation for the ladder diagram of problem statement number 4. Thank you.